Some vintage trucks were dangerous not only because of their size or power, but because of engineering solutions that would be almost unimaginable today. Would you trust a machine with limited protection, weak brakes, poor visibility, and controls far less precise than anything found in a modern truck? Back then, manufacturers were constantly chasing more power, higher speeds, and greater cargo capacity, even when that meant exposing drivers to serious risks. Some of those ideas worked for a while others disappeared because the price of progress was simply too high. In this video, we are looking at 10 historic machines that pushed engineering to its limits. Get ready for a journey through compact yard tractors, steam-powered haulers, futuristic highway giants, and experimental trucks that vanished into history. Stay with me until the end, because the #1 vehicle tried to completely reinvent long-haul transportation and became one of the boldest and most dangerous truck designs ever built. Scammell Scarab. Introduced in 1948 by British manufacturer Scammell, the Scarab was designed for work around railroad stations, warehouses, and distribution yards. Its compact size allowed it to move between rail cars, loading platforms, and tight industrial buildings where conventional trucks struggled to maneuver. Its most recognizable feature was also its most dangerous. The Scarab had only 3 wheels, with a single front wheel handling all the steering. That design gave it an incredibly tight turning radius, but it could also make the vehicle unstable in corners, especially when loaded or driven faster than intended. Gasoline versions used a 2.1-liter, 4-cylinder engine, producing roughly 28 horsepower. Some later models used a Perkins 3-cylinder diesel engine, built for low-speed pulling power and better fuel economy during long work shifts. Power went through a manual transmission with short gearing to the rear wheels. Top speed was only around 19 miles per hour, and a 0 to 60 time was irrelevant for a machine designed for short distances and heavy yard work. Its simple suspension and short wheelbase made it agile, but they also sent plenty of bumps directly into the cab. With limited driver protection and a very basic structure, one badly judged turn could make this friendly-looking little truck surprisingly difficult to control. A quick coupling system allowed trailers to be connected and released rapidly, reducing downtime and increasing productivity. That practicality made the Scarab a familiar sight on British railroads and eventually turned surviving examples into valuable museum and collector vehicles. And if this tiny 3-wheeler already carried a serious risk, the next machine raised the danger with heat, steam, and pressure. Sentinel DG8 Steam Wagon. Long before diesel engines took over the highways, the Sentinel DG8 showed how raw pulling power and real danger could exist in the same machine. Built in Britain by Sentinel Wagon Works during the 1930s, it was designed to haul heavy loads for industrial, municipal, and highway operations. Instead of a conventional gasoline or diesel engine, the DG8 used a steam system powered by a pressurized boiler built directly into the truck. Its 2-cylinder steam engine produced strong torque at very low speed, making it well suited for pulling away with a heavy load or climbing steep grades. The mechanical transmission used gearing designed for heavy work, while power went to the rear axles. Its 8-wheel layout spread the load across several contact points, increasing carrying capacity but making the truck slower and more demanding to operate. Its top speed was low by modern standards, and measuring 0 to 60 miles per hour would have made no sense. This machine was never designed to race. It was designed to move several tons steadily by using the immediate pulling force of steam. The greatest danger came from the pressurized boiler. A leak could blast operators with scalding steam, while pipes, valves, and exposed metal surfaces remained dangerously hot. Fire and mechanical failure were constant concerns. Driving a DG8 involved far more than steering, braking, and watching the load. The operator also had to monitor boiler pressure, water level, temperature, and fuel supply. One mistake could cause power loss, overheating, or a much more serious failure. These trucks served factories, freight companies, and public utilities, but they lost their advantage when diesel engines became easier to start, simpler to operate, and safer in everyday service. Today, surviving examples are treasured pieces of British engineering history. Managing 3 wheels required skill, but controlling a pressurized boiler mounted on 8 wheels demanded an entirely different level of responsibility. The next truck would prove that speed itself could become the dangerous feature. Mercedes-Benz Blue Wonder. In 1955, Mercedes-Benz built a race car transporter in Germany that looked as if it had driven straight out of the future. Known as the Blue Wonder, it was created to move the company's racing cars between factories, workshops, and European circuits at speeds almost unheard of for a transporter at the time. Under the hood was a 3.0-liter inline 6-cylinder engine, producing about 192 horsepower. It came from the same engine family used in the legendary Mercedes-Benz 300 SL. Power went through a manual transmission to the rear wheels, giving the transporter remarkable performance for a machine carrying another automobile. Its body was low, long, and aerodynamic, with a forward-mounted cab and a loading platform directly behind the driver. The suspension was adapted to support the weight of a racing car, while the low center of gravity helped keep the transporter stable. The real danger appeared at top speed. The Blue Wonder could reach approximately 106 miles per hour, an astonishing figure for a 1950s car hauler. No widely verified 0 to 60 time exists, but its performance was comparable to many passenger cars of the period. Picture this blue machine charging down narrow European roads with a race car secured to the platform. The sound of the inline 6-cylinder engine, the weight of the cargo, and the cab positioned close to the front axle created an exciting but risky combination. Its brakes, tires, and driver protection were primitive compared with modern equipment. During an emergency stop, especially while loaded, the driver needed far more distance and had no electronic stability control, anti-lock braking assistance, or modern crash protection. Enjoying this look back at trucks that pushed engineering beyond its limits? Leave a like, subscribe to the channel, and turn on the notification bell so you never miss our next video. And if a transporter capable of 106 miles per hour already sounds dangerous, the next machine was built to cross Antarctica and ended up being defeated by the ground beneath it. Antarctic Snow Cruiser. In 1939, the United States built a machine that seemed capable of conquering almost any obstacle. Created for Richard Byrd's Antarctic expedition, the Antarctic Snow Cruiser measured about 56 feet long, weighed more than 37 tons, and was intended to travel vast distances across the frozen continent. Its powertrain was highly unusual. 2 Cummins inline 6-cylinder diesel engines, producing about 150 horsepower each, drove electric generators. Those generators supplied power to electric motors at all 4 wheels, creating an advanced form of electric all-wheel drive. There was no conventional transmission. Power was controlled through the diesel-electric system, and the projected top speed was close to 30 miles per hour. On the ice, however, its real-world performance was far lower. The massive tires stood nearly 10 feet tall, but they were smooth and could barely find traction in soft snow. In some situations, the machine moved better in reverse because the weight distribution helped the rear wheels find slightly more grip. Its enormous front and rear overhangs were intended to help it cross crevasses, but they also made the vehicle harder to control. The roof was even designed to carry a small airplane, making the entire machine taller, heavier, and more complicated. Inside were sleeping quarters, a kitchen, a workshop, and a radio room, turning the snow cruiser into a mobile base. Even with all that ambition, it traveled only a fraction of the intended distance, was abandoned, and eventually disappeared beneath the ice. If this giant was defeated by its own lack of traction, the next truck tried to replace a conventional diesel engine with a turbine that belonged in an aircraft. Chevrolet Turbo Titan III. In 1965, General Motors unveiled a prototype in the United States that looked like a truck from a distant future. The Chevrolet Turbo Titan III was built to demonstrate what highway transportation might look like in the decades ahead, combining a forward control cab, aerodynamic styling, and a gas turbine instead of a conventional diesel engine. Its General Motors GT309 turbine produced approximately 280 horsepower, Rather than using pistons moving inside cylinders, the turbine spun continuously at extremely high speed, producing a sharp aircraft-like sound and operating more smoothly than many heavy truck engines of the period. Power went to an automatic transmission to the rear wheels. The prototype was not built for acceleration testing, and no reliable 0 to 60 time or official top speed was widely published. Its purpose was to test ideas, not break records. The most unsettling feature was inside the cab. General Motors replaced the traditional steering wheel with two small steering discs mounted in the dashboard. The driver controlled the truck through short-hand movements, a futuristic solution that could feel unnatural during sudden maneuvers or emergencies. The spacious cab, wide windshield, and rounded body gave the Turbo Titan III an unforgettable presence. The turbine, however, produced extreme exhaust heat, required special materials, and consumed large amounts of fuel, especially at low speeds. High fuel consumption, manufacturing cost, and mechanical complexity made the concept impractical for trucking companies. General Motors eventually acknowledged that the turbine system was simply too expensive for mass production. The Turbo Titan III never became a commercial highway truck, but it remains a symbol of an era when manufacturers believed turbine engines might replace diesels. And if steering a turbine-powered truck with two small discs sounds strange, the next machine hid an entire living space inside a futuristic command center on wheels. Ford Big Red. Ford introduced Big Red at the 1964 New York World's Fair as a vision of the future of long-distance trucking. It was an enormous experimental tractor designed to pull two semi-trailers, creating a combination nearly 100 feet long. Instead of a conventional diesel engine, it used a Ford 705 gas turbine, producing approximately 600 horsepower. The turbine delivered power smoothly and operated at extremely high revolutions, creating a sharp whistle that made the truck sound more like a land-based aircraft. The transmission was automatic, with power sent to the rear axles. Reliable 0 to 60 and top speed figures were never widely released because Big Red was a technology demonstrator, not a production truck developed for official performance testing. Its tall, rounded cab featured a panoramic windshield and an unexpectedly luxurious interior, a compact kitchen, a bathroom, and entertainment equipment, creating a genuine mobile command center. But the futuristic appearance concealed major problems. Pulling two semi-trailers required enormous room for turns and lane changes, making parking lots, intersections, and city streets especially difficult. Emergency braking with that much length and weight would have been even more challenging. The turbine produced extremely hot exhaust gases, burned large amounts of fuel, and responded differently from a diesel engine. The driver had to adjust to a delay in power delivery, particularly during starts, climbs, and sudden speed changes. High cost and poor efficiency prevented mass production. After its public appearances, Big Red vanished for decades and became the subject of rumors before eventually resurfacing in the hands of a private collector. If controlling this giant with two trailers already sounds difficult, the next truck transformed itself into a traveling stage while surrounding the driver with enormous blind spots. General Motors Futureliner. General Motors created the Futureliner in the United States for its Parade of Progress traveling exhibitions. The fleet began operating in 1940, carrying displays of science, industry, and technology from city to city. Only 12 were built, each with enormous side panels that opened into a mobile stage. After a major update in the early 1950s, the Futureliner used a 302 cubic inch, 4.9-liter inline six-cylinder engine, producing roughly 145 horsepower. It had a 4-speed transmission, rear-wheel drive, and a powertrain that had to move a vehicle weighing close to 16 US tons. At approximately 33 feet long and more than 11 feet tall, the Futureliner was never designed for speed. Its top speed was around 40 miles per hour, so a 0 to 60 time was not relevant for a machine that could barely reach that figure. The driver sat alone in a very high central position. Forward visibility was impressive, but the areas beside and immediately around the massive body created dangerous blind spots that made turning and maneuvering in tight spaces extremely difficult. Its high center of gravity, combined with old suspension and braking technology, made every stop a carefully planned event. With that much mass in motion, the driver had to recognize hazards and begin slowing down far earlier than in a conventional truck. From the outside, the Futureliner looked like a building on wheels, with red and white paint and a presence that was impossible to ignore. Once the side panels opened, it became a stage for demonstrations involving engines, appliances, scientific exhibits, and visions of the future. The parade of progress ended in 1956, and the remaining Futureliners became exceptionally rare collector vehicles. If handling this towering machine with huge blind spots was difficult, the next truck added racing speed and enough power to charge across the desert like a sports car. DAF Turbo Twin X1. There is an important correction to make here. The description involving dozens of wheels, articulated modules, and turbine engines belongs to a different experimental machine, most likely the Letourneau TC497 Overland train. The DAF Turbo Twin X1 was a racing truck built in the Netherlands for the 1988 Dakar Rally. Its configuration was extraordinary. It used two inline six-cylinder engines, one mounted in the front and the other in the rear. Together, they displaced approximately 23.2 liters and produced around 1,200 horsepower, with power distributed through a complex all-wheel drive system. Each engine had its own transmission, and both systems had to operate in precise synchronization. Any difference in power delivery could affect control, while the truck was traveling over sand, rocks, and desert ridges at high speed. Despite weighing close to 11 US tons, the Turbo Twin X1 could accelerate from 0 to 62 miles per hour in approximately 8 seconds and exceed 124 miles per hour. That was sports car performance in a massive, high-riding machine carrying a large amount of fuel. Heavy-duty suspension, enormous tires, and four-wheel drive allowed it to cross dunes and punishing terrain. Inside the cab, the driver and navigator endured heat, noise, violent vibration, and sudden direction changes. Its danger came from the combination of mass, speed, and enormous power. During the 1988 Dakar Rally, a fatal crash involving another truck from the team contributed to DAF's withdrawal from the event. The Turbo Twin X1 became a rally legend and a symbol of an era when manufacturers tested the limits with far fewer restrictions. On some sections, it was fast enough to challenge the race cars, and if putting approximately 1,200 horsepower into a rally truck already sounds excessive, the next design tried to reinvent the entire cab in the name of aerodynamics. Colani truck. It looked more like a spacecraft than a conventional semi-truck. Created by Swiss designer Luigi Colani, the concept was intended to demonstrate how far aerodynamics could reduce fuel consumption through rounded surfaces, a forward-mounted cab, and a body that concealed much of the running gear. Because several Colani truck prototypes were built over the years, specifications varied from one version to another. Some used Mercedes-Benz diesel truck engines with an inline six-cylinder layout, a manual transmission, and rear-wheel drive, with efficiency at highway speed taking priority over acceleration. The chassis and suspension were based on existing heavy trucks, but the wide, enclosed body made it difficult for the driver to judge the vehicle's true dimensions. In tight spaces, accurately estimating where the nose and sides ended required constant attention. The enormous curved windshield offered a panoramic view, but it could also create reflections and visual distortion in rain, artificial lighting, or low sunlight. The cab sat very close to the front of the vehicle, leaving little structure ahead of the driver to absorb the force of a collision. Blind spots required special mirrors and, on some versions, side-mounted cameras. At the time, those cameras were still unusual and far less proven than the systems used today. Cab access, routine maintenance, and replacement of body components were also more complicated than on a conventional truck. Inside, the central driving position and futuristic dashboard created the feeling of piloting an aircraft. The Colani truck never reached mass production, but it influenced aerodynamic research and demonstrated that extreme efficiency could create serious practical and safety challenges. And if this capsule-shaped cab already placed the driver near the very front of the truck, the final machine went even further by positioning the trailer and its cargo directly above the cab. Steinwinter Supercargo 2040. In the early 1980s, German engineer Manfred Steinwinter introduced one of the most radical ideas in trucking history. The Supercargo 2040 replaced the conventional tractor with an extremely low cab positioned directly beneath the front of the semi-trailer. The prototype used Mercedes-Benz components, including a 14.6-liter V8 diesel engine producing approximately 375 horsepower. Power went through a manual transmission to the rear wheels, using parts adapted from existing heavy trucks. The goal was to create more cargo space without increasing the vehicle's total length. In practice, that meant placing several tons of freight directly above the driver's head, creating a level of confinement and exposure unlike anything found in a normal tractor trailer. Its extremely low position severely reduced visibility in traffic. Next to buses and conventional trucks, the Steinwinter practically disappeared below the window line, making it harder for the driver to see surrounding traffic and harder for other motorists to notice the vehicle. Testing revealed engine cooling problems and a tendency toward understeer, meaning the truck resisted turning and continued traveling straighter than the driver intended. With the cab positioned beneath the trailer, any loss of control could have especially severe consequences. Rear-end collisions presented another serious danger. Instead of contacting the stronger, higher structure of another truck, the low cab could strike directly beneath the rear of the vehicle ahead, placing the occupants in one of the most vulnerable positions imaginable. Mercedes-Benz and other partners eventually abandoned development, and the Supercargo 2040 never entered production. It became a legend among truck enthusiasts because it attempted to solve a real transportation problem with a solution that was as brilliant as it was dangerous. That is how the most radical truck on this list disappeared. It was not a failure of imagination. It was proof that gaining more cargo space could come at the cost of driver safety. These trucks prove that transportation evolved through bold ideas, costly mistakes, and risks that would be unacceptable today. 3 wheels, pressurized boilers, turbine engines, forward control cabs, and tons of cargo directly above the driver showed just how far engineers were willing to push the limits. Many of these projects disappeared because they were too expensive, too difficult to control, or too dangerous for everyday use. They taught valuable lessons about braking, stability, visibility, fuel efficiency, and occupant protection. Now tell us in the comments, which dangerous feature surprised you the most? How many of these trucks had you seen before? And which one deserves to return with modern technology and modern safety systems? Leave a like, subscribe to the channel, and turn on the notification bell. Those actions tell YouTube that this content matters, help the channel continue growing, and allow more truck enthusiasts to discover these forgotten machines and incredible stories. See you in the next video.